Hello everyone, this is Mr. Zarzak, and in this tutorial I'll be discussing the error analysis section of the Projectile lab. Every experiment we perform in physics this year will contain several sources of error, and identifying those errors and how we can improve upon the labs that we do in class will help us become better scientists and better understand the experiments we perform. This question is taken directly from the lab handout. I want to point out that right here, errors is plural, and so when writing your error analysis, you want to try to identify multiple sources of error. A good rule of thumb is at least 2, and you want to strive to impress your teacher, so I would suggest trying to find 3 errors minimum. The list I'm about to present you with is by no means complete. After identifying the sources of error, I'll address what could be done to potentially improve upon the lab and minimize these errors. Lab teams were provided with a meter stick to measure the length of the ramp. However, everyone's ramp was a distance that was greater than 1 meter. This is a potential source of error because in order to measure the total length of the ramp, the meter stick had to be picked up and moved to get that total measurement. This introduces a source of error and reduces the precision of the measurement. When setting the initial ramp height using the meter stick, there's another potential source of error here because our meter sticks have been in use for several years and the ends have been worn down over those years, creating potential error in the 0 point of those meter sticks and hence potential error when setting the height of the ramp. When timing the ball moving from the top of the ramp to the bottom of the ramp, there are several potential sources of error concerning the timing. One would be the reaction time for starting and stopping the stopwatch, and this error can be magnified if one person releases the ball while a second person is in charge of starting and stopping the timer. There also is potential for inconsistencies for stopping the timer at the end of the ramp because it requires you to make a judgment as to when the ball reaches the bottom of the ramp. The end of the table. That might be by the clicking of the ball when it lands, or maybe by a lab team member's hand at the end of the ramp. When performing calculations to determine the time that the ball will be in the air moving from the top of the table down to the cup, and subsequently the time the ball would be moving sideways off the top of the table to the cup, air resistance is ignored in the calculation. This is a potential source of error because the air resistance could potentially increase the time that the ball is in the air, but it could also decrease the distance the ball travels horizontally. The edge or overhang of the table provides another potential source of error. The cup is placed on the ground some horizontal distance from the end of the table, and so your lab team needed to somehow figure out a way to mark the end of the table on the floor below and then measure from that location to where the cup would be placed. Because your team somehow needed to measure where the edge of the table lined up with the floor, that leads us to another potential source of error. Especially as the ramp height is increased from 10 to 15 to 20 centimeters, the potential for the ball to bounce at the bottom of the ramp when striking the lab table increases. If the ball bounces on the lab table, then this becomes an angled projectile problem, in which case the physics equations used in your analysis in the lab no longer become valid because there's some vertical component to the initial velocity of the ball as it leaves the table. The time the ball moved through the air was calculated by measuring the height of the table down to the ground. The trials were conducted using a can that had a height that was greater than 0, and therefore the vertical displacement of the ball was actually less than the height of the table. Another error involving the can was success or failure of a trial was determined by whether or not the ball went into the can. But the ball diameter was much smaller than the can diameter, so there was actually some built-in margin for error for your trials. Again, this is by no means a complete list of all the potential errors in this lab. However, I've tried to give you enough things to think about, and now I'd like to focus on what we could potentially do when reperforming the lab to reduce or minimize these errors. To reduce the error in measuring the length of the ramp, a tool longer than the ramp should be used. Perhaps a 2-meter long meter stick or a tape measure could be used instead of the meter stick. As for the height of the ramp, a tape measure might be a more appropriate choice because any wearing on the edge of the meter stick is eliminated by, well, eliminating the use of the meter stick. One way to minimize or reduce errors in timing for the ball moving from the top of the ramp to the bottom of the ramp would simply be just to perform more trials and take the average of those trials. In addition to performing more trials to minimize any errors in timing, one lab team member should be put in charge of both releasing the ball and starting the timer. This will help minimize the effects of any human reaction time. The metal can also be placed at the end of the ramp to provide a consistent stopping point for both the ball and the timer. Using the can has an added benefit because when the metal ball strikes the metal can, the sound of the impact can be used as a cue to, well, stop your timer. Since replacing the lab tables in the classroom isn't really a practical option, another way to find the exact point to where the edge of the table lines up with the floor is to use a device called a plumb bob. A plumb bob is just a string with a mass tied to it, and because gravity points straight down, just by allowing that hanging mass to come to rest, you have a perfectly vertical line straight from the top of the table down to the floor that can be marked and used as a reference point for measuring the distance from the edge of the table to where to place the can. I've seen students employ several different and creative methods to reduce the bounce at the end of the ramp. A simple method would be using a note card to smooth out the transition of the ball moving from the angled ramp to the flat table. Even a little bit of a curve on a single piece of paper can make a big difference in reducing that bounce. As for eliminating any error caused by not accounting for the can height, well, simply account for the can height. Measure its height, subtract that value from the height of the table, and recalculate the time the ball spends moving from the top of the table down to the can, as well as the horizontal distance the ball travels during that time. An alternate approach to dealing with the can height would be to eliminate the can altogether. When the ball lands, its landing position can be marked using some carbon paper, which, if you have a checkbook, that's the paper that's used to make, well, a carbon copy of the check that you write. For a more 21st century solution, the ball can also be videoed while moving through the air using your phone, and then the video can be analyzed to see where the ball strikes the ground, and then that value can be measured just by placing a meter stick on the ground. The list of errors I've provided in this tutorial, along with possible improvements to the lab, are by no means complete. Hopefully I've just given you some things to think about, both for this lab and for all the experiments we performed this year in physics. Keep in mind that I've provided you with bullet points and then spent a considerable amount of time providing extra detail on those points with this audio commentary. When you're writing up any error analysis for labs in physics, please be sure to use full sentences and to explain in detail what your lab errors are, both what the sources are, how those errors could potentially affect your results, and ways to improve upon the lab if performed in the future. This is Mr. Zarzak saying thanks for watching, and I'll see you in class. Bye-bye.